exist without IBM. It's called the biggest accounting operation of all time.
1937, IBM China.
In 1938, millions of children first hear the phrase, "Please fill in the bubble completely," thanks to the IBM 805 International Test Scoring Machine.
1939, IBM demonstrates an early form of email at the New York World's Fair.
1940, a vacuum tube that processes information thousands of times faster than ever before.
In 1941, IBM hires Dr. Michael Supa to make its products more usable by the visually impaired. Dr. Supa was blind.
IBM believes in cultivating and developing the best talent in the world. That's why we introduced the Disabled Employee Training Program in 1942.
In 1943, Ruth Leach becomes IBM's first female vice president.
1944, the Automated Sequence Controlled Calculator.
The first Watson Scientific Lab opens in 1945 at Columbia University.
T.J. Lester, IBM's first black sales representative, is hired in 1946.
By the late 40s, IBM products are being used in 79 countries around the globe. They're really growing.
The Selective Sequence Electronic Calculator, the first computer that could modify a stored program.
The card-programmed electronic calculator.
1950, IBM's in Israel.
In 1951, we started work on the IBM 701, the world's first mass-produced computer. It's the machine that carries us into the electronics business.
In 1952, IBM Chairman Thomas J. Watson hands the reins over to his son, Thomas J. Watson Jr., and the modern corporation continues to evolve.
In 1953, Watson Jr. issues the company's first equal opportunity policy letter. The Civil Rights Act comes over a decade later.
I was born in 1954. That same year, an IBM computer translates Russian into English. A first.
1955年、IBM の700に電子データプロセスマシンが誕生しました。
1956, RAMAC.
1957, Fortran.
Watson Jr. hires the best architects and designers in the world to work with IBM. Good design is good business.
More affordable and easier to use than anything before it, the IBM 1401 is the first computer in the world to sell 10,000 units.
1960, the Stretch Computing System.
1961, la machine à écrire électrique, Unicode.
In 1962, IBM develops the Sabre reservation system for American Airlines. What once took hours can now be done in real time.
The following year, in one of the riskiest decisions ever made in business, Watson Jr. bets the future of the company on the IBM system.
The System 360 takes several years and $5 billion to develop, making it the largest privately financed commercial project in history.
For the first time, the power of computing is accessible to organizations of all sizes.
In 1966, IBM researcher Robert Dennard invents DRAM, memory on a chip. Eventually, billions would be produced.
1967, Benoit Mandelbrot. He invents fractal geometry, and a new branch of mathematics is born.
By 1968, IBM's 10-year partnership with America's space program is converging on their ultimate mission.
As we explore the reaches of space, let us go to the new worlds together. Not as new worlds to be conquered, but as a new adventure to be shared.
Il database relazionale rivoluziona il modo in cui i dati sono accumulati e processati.
1971.
Computers can talk.
IBM's first automated teller machine is introduced in June of '72.
In 1973, IBM introduces the UPC barcode.
1974, Systems Network Architecture.
1975, the IBM 5100, the first portable computer. Kinda.
1976, the first laser printer.
IBM's data encryption standard revolutionizes the way information is protected.
IBM introduces the first mini computer to feature a built-in relational database.
The first kanji computer terminal is introduced in '79, the year I was born.
RISC. It's invented by IBM in 1980, and it's still the basis of most microprocessors today.
IBM introduces the personal computer. We expect to sell 240,000 units. We sell 2 million over the next 3 years.
The Tokyo Research Lab opens in 1982.
IBM introduces the System 36, an easy-to-use business computer featuring 2,800 help screens.
Is a 1 million bit memory chip possible? In 1984, it is.
In 1985, John Akers becomes IBM's 7th CEO.
1986, Gerd Binning and Heinrich Rohr become the second and third IBMers to win the Nobel Prize. The first was Leo Isaki.
1987, Georg Benmarz und Alex Müller gewinnen für ihren Durchbruch in Hochtemperatur- und Superleitfähigkeit.
1988, AS400.
Silicon germanium chips.
1990.
What does an IBM scientist do to prove he can move atoms? He rearranges them to form the letters IBM.
IBM researchers invent a computer chip that can move 8 billion bits of information in a single second.
ThinkPad.
The early 90s. Tough times for IBM. Some people wonder if the company's going to make it, but in 1993, Luke Gerstner arrives and takes IBM in a whole new direction.
IBM refocuses everyone on the customer. How?
Solutions.
Systems, software, services, e-business. By 1997, IBM is back.
The same year, IBM's Deep Blue defeats the reigning grand champion of chess.
A thrilling win for IBM's Deep Blue.
IBM embraces Linux, and the era of open source innovation is born.
The President of the United States awards the National Medal of Technology to IBM, the 7th they received so far.
Carbon nanotubes.
Millipede technology stores 3 billion bits in a space this big.
In 2003, Sam Palmisano becomes the big boss. The world will soon become smaller and flatter.
The World Community Grid.
Bluetooth, the fastest computer ever.
这个电脑说英文。
This computer speaks English.
Patents.
What a planet.
On the cities.
After a century of innovations, we're just getting started.
100 is a big, big number.
What will the next 100 years bring?
I use the past to predict the future.
I'm working on the next big breakthrough.
In 10 years, supercomputers could use 10 times less power and run 1,000 times faster.
I'll be able to sequence a genome so we can create personalized medicine.
The whole world is data.
I'm using data to help detect the onset of disease.
I've discovered a way to build curiosity into the system.
I'm working on a system that can think like you.
We've always been working for the future.
That's what I'm working on.
That's what I'm working on.
That's what I'm working on.
I'm an IBMer.
I'm an IBM.
I'm an IBM.
I think that you have to have more than just a machine.
We must study, listening, observing, and thinking. All of the problems of the world could be settled easily if men were only willing to think.
facing now are too complicated for a single human to figure out all by themselves. And so the entity that's going to solve the problem is going to be a combination of humans and machines working together to make a kind of integrated intelligence.
And one way of framing the core research question is, how can people and computers be connected so that collectively they act more intelligently than any person, group, or computer has ever done before?
At the highest level, you could imagine a truly intelligent computer that would understand situation, would be able to figure out explanations of events and be more inventive with respect to scenarios, overcome the limits of imagination and creativity. So there is really no limit to what computers ultimately could do.
We have big problems to deal with as a country, cost overruns, rampant inefficiency, and now we have tools that can really help us deal with that, where I think 10 years ago we didn't. We had relatively primitive tools. So I'm excited for the next decade. I think that we'll be much better doctors, we'll hopefully get much better healthcare as patients, and some of these tools are going to help us get there.
If I look forward 30 years, the way we will use computation will be very much the way we're having a conversation today. The barriers of dialogue will be erased. We will have systems, we'll have computers that understand our shortfalls and provide insight, much like a tutor or a mentor would do, or a good parent does.
I think when people imagine machines and people working together, sometimes it's a little frightening idea of having a computer help you think. But I imagine it's being kind of like a violin. That if you look at a violinist and a violin together, it's really the violin that's making the noise. But the violin and the violinist are able to do something much more than either of them could do separately. And I think the future is going to be humans and machines working together like that, like the violinist and the violin.
In today's world, the volume of unstructured information is growing at an enormous rate. We really need better technologies to help make sense of it and make better decisions. At IBM, we're seeing a new era of computing, starting with the tabulating era, then to the programmable computer era, and now cognitive computing systems which expand the boundaries of human cognition, become smarter with use, and have a much more natural interaction between the human and the computer. In the area of artificial intelligence, there were a lot of amazing ideas, but computational capabilities just weren't ready for them. Watson suddenly makes some of these crazy ideas possible. At the core, we're trying to leverage knowledge the way humans record and communicate it, natural human language, and in particular, text. Its initial introduction to the world was as a competitor on the Jeopardy quiz show. In the healthcare space, we're approaching it as a support tool to expand the physician's cognitive boundaries by giving them deeper access to much larger volumes of information. The history associated with the patient, the journal articles, clinical results, best practice guidelines, etc. That volume of content is doubling every 5 years. Physicians have precious little time to keep up with everything. A system like Watson can leverage the computer's ability to deal with huge volumes of data, understand the knowledge that's contained within this data, apply it to the problem that the physician is trying to solve, give them different alternatives to consider, and in particular, the underlying evidence that supports those alternatives. That basic problem-solving pattern applies to a wide variety of industries. Any area where you have complex problems that you're trying to solve, we're adapting the computer technology to work better with the way humans want to work so that it's a more natural relationship between the human and the computer.
"100 years, very long time. Bet you didn't know IBM used to make meat slicers too. We've come a long way. So IBM Research, it was the later part of that video, that some of the technology that IBM Research is working on, that cognitive part. That's in the software space, but we're still working on the hardware space as well. And we have research labs all around the world. The one I'm located is the one called Watson. It's in Yorktown, New York, about hour and 15 minutes north of New York City. And that Watson technology that he was just referencing originated there, and that's why he got the name Watson, okay? And actually, as we go through this and we start the demo, I'll show you where you can actually use some of that technology today. So in IBM Research, we focus on a lot of different things. These labs have different technology areas. The Almaden lab in California heavily focuses on analytics, storage, and healthcare. Brazil, natural resources, smarter devices. They're doing a lot with mobile devices as well. If you go to the App Store or to the Google Play, you'll see a lot of IBM apps on there, and a lot of those come from IBM Brazil. And we're constantly expanding as well. So in 2011, that's when we actually opened Brazil. In 2012, 2012 was Africa. So this is the Yorktown building where one of my offices is. I have another office in Poughkeepsie, which is about another hour north of this facility. This is the building I think you saw in the background in a lot of that video. This is from the view from the sky. This is IBM Research. This is the headquarters. It doesn't look this nice at the moment. It's full of snow and it's very cold. But some of the things you find there, they actually have clean rooms where they actually do chip design and chip prototyping in this facility. There's a lot of data centers, and there's not your typical production data centers. It's more of a development data center for researchers to put their systems in there. This is the actual Watson computer. It's a number of racks of Power 7, IBM microprocessor. This is Blue Gene. These are racks and rows of Blue Gene systems. This is a supercomputer. So my organization in IBM, there's several organizations that focus on specific industries and specific technologies, for example, cloud and services. My organization is in a unique position where we work with all those different areas. And we also provide information technology services for research. But we're really the living lab for IBM. A lot of the emerging technology that IBM works on with partners or innovation is really applied to IBM Research. So when we started cloud several years ago, 2007, we were the first one to actually put up a cloud, an internal cloud for IBM to use, for IBM Research to use, and I'll get into that a little bit more. But so we get to work with the researchers in a lot of different areas and bring that technology to life in our environment first before we actually demonstrate it to customers. So these are some of the things that we've worked on in the last several years. Starting with InfoStreams, it's actually a series of IBM products. It originated in IBM Research. Research Compute Cloud, that existed for about 5 years, back in 2007. And as we matured from our data centers where researchers had equipment in their offices, we started moving the equipment into a development data center. And as we did that and optimized, researchers said, it would be nice if we can just have some automation to provision these resources. And that's where the Compute Cloud originated from. Deep Thunder is another technology that IBM Research does for weather modeling for smarter cities. It's highly accurate, and it goes down to a 1 kilometer resolution. So within 1 kilometer, we can predict what time of day there will be a thunderstorm, rain, or any type of precipitation. Starting here, this is a picture of a data center temperature. So the red spots are the hotter spots, and the green spots are the cooler spots. But this is called the mobile measurement technology that we use and developed in IBM Research to optimize the cooling and power consumption of a data center. This is the cart that originally goes to the data center to get a sampling, and once it gets that sampling, then we can monitor real time with other sensors. Today, we actually have a robot that does that instead of actually us doing this manually. There's a robot that goes throughout the data center and captures those data points. And then, of course, you know, we worked on Blue Gene and we work on Watson, which is the computer that participated in that game show hosted Jeopardy. So this is kind of what we've done in the last 10 years, my organization. When you walked around back in the early 2000s in that research facility, you walk into the researchers' labs or offices or even closets, you see this. All right, in some labs you still see that, but what we wanted to do is really optimize and create a development data center for researchers to do their work. And we did that. So it took a while, but we got to a place where we can actually have a data center not only for researchers to do work, but to actually demonstrate to our customers what the technology we have in there. And that was the goal. So this is actually a briefing center within our data center that we bring customers to. And we show some of our automation. A lot of these screens here are monitoring activities within the data center. This one here, for example, is monitoring the requests coming from the worldwide IBM, creating new VMs, virtual machines, on the research compute cloud. We monitor cooling, we monitor temperature, as I indicated, and behind this glass here, this is called e-glass. So when you first walk in there, you don't see the data center, but with a flick of a switch, the glass goes transparent and you see the equipment behind there. So this is Watson again. These are Power 7, but the data center extends way in the back and to the side. All right, so now I want to give you a quick overview of IBM's cloud platform. So, cloud is everywhere. Everybody's talking about cloud, right? And there's even a Hollywood movie that references cloud, and nobody understands the cloud. It's up in the cloud. Well, we like to think we do, right? So when I talk about cloud, I like to talk about the users, the roles that use the cloud. So starting at the lowest layer, an IT manager or an IT professional will use an infrastructure as a service cloud. So they can provision infrastructure on-premise within their data center or off-premise, such as soft layer. And you can provision compute, network, storage, and various other services for your infrastructure. A level above that, we talk about platform as a service, and really it's geared towards the developer. This is a service that developers use to compose and create applications for them or for their users. And then at the highest level, we have business as a service or software as a services. And this is your email, Netflix, things of that sort. And IBM has 100+ solutions of business as a services that sells to customers. Smarter Cloud for sales and commerce, marketing, city operations. Those are all services that are at the highest level of the IBM Cloud Platform. When we talk about platform as a service, and this is where I'm going to spend most of the time in this presentation, actually showing you this. So I'm not going to spend too much time here, but this is our platform as a service where developers can go get started quickly in creating an application with a lot of the services available to you, such as databases, push notification for mobile, security authentication. I'll show you all that in a little bit. And then, of course, you need other things to build your software. So Bluemix kind of sits in the middle, but then you have this IBM DevOps services that allows you to collaborate with your friends or your other developers. So this represents a Git repository. It has an agile tool for processing. You don't have to use the Git repository within JazzHub. You can use GitHub if you like, but this will allow you to do that, gives you that flexibility. And then after your application is built, you need to manage it. You need to monitor it, and that's where IBM Service Engage has all these services to manage and to monitor your application. All right, so when we're talking about infrastructure as a services, IBM has a lot of different options. We acquired SoftLayer almost 2 years ago, which is an infrastructure as a service. And so you can provision VMs, you can provision storage, you can provision bare metal. Now, that's the main differences with IBM's cloud offering infrastructure as a service compared to anybody else. You can actually provision bare metal servers, and others are usually just virtual machines. We also have software and hardware that you can purchase and build your own cloud within your data center. So that's called on-premise. What we see people doing, and when we're working with customers, is they create a hybrid. They'll have an off-premise cloud that they'll use. They'll have an internal cloud, and then they have to tie them together. And this is what we see a lot, this hybrid solution. And IBM has, again, a lot of products and solutions around that hybrid to tie the two together in a secure way. So these are all the systems that IBM builds. There's countless systems. I'm not going to show them all, but we still make mainframes. We're still selling a lot of mainframes. And we're still selling a lot of different range in servers sold. The power is considered the middle range, and then X is the lower range. So SoftLayer has many data centers across the world. So when you go onto SoftLayer, you can get a free account on SoftLayer. You get 30 days free. You can go check it out. But you can provision resources all around the world. And it's got a complex network topology as well. But we in IBM Research actually are using SoftLayer for our own cloud computing. Not only do we have a data center in an internal cloud, but we talked about Research Compute Cloud, and it said it existed for 5 years. That doesn't exist anymore. We actually created a system that allows researchers to provision resources in SoftLayer as if they were located in our own data centers. So that's what we've done over the last couple of years, and we have resources all over the world. London, Australia, Amsterdam, and of course in New York, Washington, D.C., and San Diego. So one of the advantages I said before that SoftLayer provides compared to some of our competitors is the bare metal provisioning. VMs are good, but sometimes you need bare metal. And here's just a rough calculation of the performance you get on some of these systems compared to virtual machines. So in price and in performance, you get almost 5 times better than an equivalent virtual machine. So this is where a lot of gamers actually go and get resources for their games. So SoftLayer, a lot of the clients in SoftLayer are gamers. And then, of course, IBM is also very focused on security, especially when we're talking about putting your crown jewels in a public cloud. So we have a specific area in research that we talk about security and do research on security. So all this is IBM's portfolio. So infrastructure as a service, compute, cloud, networking, platform as a service, DevOps, security, integration. And again, I'm going to spend some time in this middle area here, and then, of course, there's the business as a service as well. Oh, sorry. All right, Bluemix. Bluemix is a platform as a service, as I mentioned before. It was designed for developers, for you to get started quickly, and be flexible. So any language, Java, Ruby, Node, Go, PHP, you choose. It's a platform for any language. And of course, it has a lot of mobile backend as a service as well. And again, it was designed to be simple to get you up and ready quickly. So it consists of several things. Applications is the stuff that you build. There's a set of number of services. There's build packs. So if there's a starter pack, for example, that doesn't exist and you want to create your own, you can. And we'll go through that a little bit. So when you first go on there, some of the things I'll take you through, a boilerplate is a container or application associated with a runtime. A runtime is those application platforms such as Node, Go, PHP, and Ruby. And then the build pack allows you to create new things. So this is not just IBM created. There's a community behind this. And when we log in and go on to Bluemix, you're going to see IBM specific packages, you're going to see community specific packages, and you're going to see third party. Third party packages are those that the community submitted and then have been IBM certified. So what I like to do now is actually show it to you. So let me see if I'm logged in here. Yes. All right, so when you first go on to Bluemix. It's bluemix.net. Just type that in your web browser. You go into the main page, and you can log in or you can sign up. It's 30 days free. After the 30 days, it's still free. You have 375 gigabyte hours free every month. Right? So what does that mean? Well, this number here is key. Okay? So every month after the 30 days, for the first 30 days, everything is free. But every month for the after that, you get 375 gigabit hours. So if you have an application that uses 1 gigabit of memory for 1 hour, you just spend 1 gigabit hour. It's very simple. If you have an application that has 2 gigabit of memory, consumes 2 gigabit memory, and runs for 2 hours, you just ran 4 gigabit hours, right? It's very simple math. All right, so this is the main dashboard. It's a web UI. Once you log in, you can configure your local environment to use a command line if you prefer. You can use this web UI, you can use a command line, and the command line becomes more interesting when you're doing some automation. So you write your own program or your own build process to create new resources within this platform. Okay? So, and then here is a space. I have a development space, I have a production space, I have an organization. I can add people to my organization, other developers that I would be working with. I can do that. So let's go through it and create a first application. So typically you would go to the catalog, and at the top of the catalog, we have boilerplates. Boilerplate is a starter pack that has a runtime and an example application to get you started quickly. And then there's various ones. There's Internet of Things, there's Java, Cache Web Server, there's some of the Node JS stuff here, with Node with Cloud, which is a IBM JSON NoSQL database. And then if you scroll down, you see some of the runtimes. You got Java, you got Node, Go, PHP, you got Ruby on Rails and Ruby with Sinatra. It's a lighter version than Ruby on Rails. And here's all the technology around that Watson, that cognitive that we talked about, that you saw some of that video. So you can write an application and use some of these technologies. So if you want to look at one of these, for example, so if you click on it, you can get more detail. And the nice thing about some of these, especially the beta ones, they're free. So you can click on View Docs to get more information. And you can read about it, how it works, what it does. You can actually get a demo. You can use it and deploy it on Bluemix just by clicking a button. All right? So those are some of the services. Then there's services around the mobile space. Advanced mobile access and then single sign-on as well. So it allows you to connect to different services that already exist out there for authentication, such as Facebook, Twitter, all those, Gmail authentication. There's services around DevOps. And we're going to be focusing on the track and plan a little bit later. There's web application services as well. There's integration services. There's data bases, all different flavors, including the original relational database, Mongo, DB, there's big data. And again, if you see some of the things on the bottom, it says IBM on some of these, and others say experimental, others say beta. Third party, those are the ones that were contributed by a third party and are IBM certified. There's some up here that are community provided. So these are all provided by the community here. Right? So this left hand here just allows you to filter by that area you're looking for. So what I would like to do is actually go ahead and create one of these. So I'm creating a Node.js application with a cloud database, which is a JSON NoSQL database that IBM has. So I'm going to deploy it on my dev space, and I'm just going to give it a simple name here. So what this technology does, it uses, it has its own set of containers, and it isolates an application. So it doesn't deal with virtual machines, although you can deal with virtual machines. We just actually introduced virtual machines into this environment as well as other containers. But here's, so my application is created. I can go back to the dashboard, but let me show you some of these things here. So this is the overview. So this is my application, and I chose, or it chose, 512 megabytes of memory for it, and I have 256 left. As an IBMer, I get 1 gig free. Here's the cloud database, NoSQL database that provisioned and bound to this application, and then it also bound another service called monitoring and analytics. All right? So the app is up and running, and here's the URL. So if I click on that, it actually launches the app. And this is the example app it came with. So it's just a simple favorites organizer that allows you to create favorites. Hopefully this will become one of your favorites, Bluemix.net. All right? All right, that's it. So let's go back and look at what this is actually doing. So the very first thing we want to do is actually start coding, right? So there's a couple ways you can start coding with. You can actually use the DevOps services that I'll show you in a moment, which actually has a web IDE. It's actually very impressive. Or you can actually, if your favorite IDE is Eclipse or the command line, you can download the tools and install them on your machine locally that communicates back with Bluemix. And in fact, there's the tooling for Eclipse. When you actually have, under the servers, you'll have your Bluemix server in there. And so you can start and stop it right from your Eclipse environment. You can deploy it just like you do on the other servers like Tomcat. Back to overview. So the first thing I want to do, though, is add a Git repository. And as I demonstrated before, or I mentioned before, Bluemix is one environment, DevOps is another, and this integrates with our DevOps services. I'm going to go ahead and hit continue. What this is telling me is that every time I push new content to this Git repository, it's automatically going to publish the updates to my server. All right, so I created my Git repository. There's the URL. All right, so let's go edit some code. Again, like I mentioned before, this is our DevOps services, and it's a web IDE. So if you don't want to launch your IDE on your local system, you can use this one. So here's my application. This is the name that I gave it. Here's all the files associated with it. Since this is a Node application, the main app is app.js, and this is a web application, so it uses the Node Express, and it uses Jade for its template engine. So anybody know Node? So this is a typical application, and you can use the IDE right here. Where'd my cursor go? And this is not just a regular web IDE. If you type, it actually gives you context-sensitive help, just like your Eclipse. So it's actually very impressive. So it understands the language, it understands the variables you're working with, all within the web browser. All right? So let's have a little more fun. Let's see. You can go to if you were to make changes, you'd see your changes in here and you would be able to commit them. So here's the files that have changed. Since we haven't committed anything, all of them are in there. So you can select all. So you can go in and say, and it puts it in a Git repository. And because we chose to have it automatically deployed, your application will be deployed automatically again. All right, so what I'd like to do next is actually show another application that I created Monday night. So the motivation for this application came from this. This is what I get for hiring one of you. Brilliant programmer. One of the best interns I had in many years at IBM. You may know him. His name is Michael Santos. Of course, he put this on the board in the coffee room, and I didn't see it until months later. I had to make a correction, of course. You know, it was the other way. All right, so that's the motivation for the program. So I was thinking, you know, there seems to be a lot of rivalry between soccer teams all over the world. And wouldn't it be nice to have an application that actually does and assesses, you know, which team is actually better based on 25 years of history, you know, what their records are, what their player stats are, what the schedule of each team is each year. And then for each one of those elements, give it some quantitative value, and then add them all up, and the one with the largest number is the better team, right? Simple, right? So that's what I try to do with this application here. Where's my cursor? All right, it's a very simple application, it's just a web interface and using Node. Node is where all the code is written, okay? So the very first thing is, let's go look at the code. This is firing the DevOps again, and it's going to bring up that web IDE so I can show you what I've written there. And again, it's Node with Express using Jade as a template engine. So let me start with the templating engine here. So the templates are in views. There's three. There's the actual page, which is very simple. It has an HTML and Jade is very simple. You just type in the HTML and it does the opening and closing things. And then I include the body, or the head and the body. So the body is where most of the content is. And so it's very simple. I have 2 drop-downs that populate with Liga Portuguesa, all the teams in there, okay, for Liga. Well, most of the teams. I didn't put all of them in there. And then a button at the bottom that I click go, and it fires off into the app.js that actually calls the method that does the comparison. Very simple. So the main program is right here, app.js, and the body of the route, which is just a slash, and then you can specify when you hit the go button, it'll you specify team 1 and team 2, and it calls this this special method here called compare team, and you pass the team 1 and team 2. So let's go back and actually launch that application. So it's already running. That's it. So 2 drop-downs and a button. So if you select a team here, say Sporting, and one of these teams here, and you click compare teams, Sporting, right? So let's choose another team here. Sporting. That's right. I mean, come on, this doesn't lie. That's all right, let's change sport. Let's put somebody else in there. Let's put Porto and Benfica. Good program, right? All right, so let me show you that method. There it is at the bottom here. So I need some help with this, all right? And this is where you come in, all right? So this whole DevOps services is meant to collaborate. And because I have this in DevOps service, I want to invite you. I'm going to send you my email is going to be on the last slide. So send me an email, send if you want to participate, and I'll invite you to this project, and we can work together on this. It'll be fun. And the way we do that, go back here. So you send me an email. Oh, I forgot the @ Sorry. And that concludes my presentation. We do have a few minutes, so I'm here to answer any questions you have. But here's my email. If you want to participate and help me with that application and do the actual code to do the analysis, we can do that. All right? Thank you very much for your time. It was a pleasure.
Portanto, muito obrigado, Carlos Fonseca. Tenho agora para distribuir um disco Tera da Samsung, disco externo. Entretanto, também tenho aqui algumas t-shirts que vou mandar e quem ficar com ela é o primeiro servido. Portanto, força.
Can I use random.org in your PC?
What do you want to do?
Random.org. Okay. Sorry, I don't use Mac. Can you show me the browser?
Yeah.
É só, tenho aqui o PC, pronto. Vá. Não. 140. Pergunta. Pessoal, se alguém tiver perguntas, posso passar o microfone. Pronto, com licença.
Carlos, here.
Hi.
Hi, my name is Alexander. I'm a chemical engineer, although a public worker. I'm an IT contact here in the Technical Institute. Formerly, 10 years ago, I worked for a company called Infinia, where the motto was never stop thinking. I would like to speak a little about your slide 18, for to have disconnected your laptop. Do you are aware of any IBM Watson or IBM Watson kind of computer installed in Luxembourg? Because I received information from a system named Isabel that compared itself against Watson's, saying against Isabel, Watson is a kid. Of course, this was spoken in our Portuguese. Does IBM Watson speaks our Portuguese?
Does it speak? So the question is, does IBM Watson speak Portuguese? I'm not certain that it does, but today it speaks English, obviously. But it could be trained to speak any language. I'm not sure the details. I can send me an email. I can find out for you.
Mais alguma pergunta?
First of all, my colleague was asking for the email again because they removed it. So
Sure.
if you could just send them, say it out loud, I think.
Yeah, it's
Write it?
CA Carlos A. Fonseca, CA Fonseca at us.ibm.com. Okay?
Okay. For my actual question, I was just wondering, there's a lot of platforms, I'd say similar, but I don't think as complex as Bluemix. But I was wondering, after the little gig about football and everything, or soccer, as you call it, did you see Bluemix more for the individual programmer, the guy in the basement trying to make it as their own, or do you actually envision it to start sinking into the companies as a standard? Thank you.
Agora vamos ao sorteio do prémio. Acabamos agora as perguntas. Só aqui, um momento.